Oh. Is it supposed to look like that? I don't think so. Sorry. All right. Are you all here building AI startups or startups that are thinking of building AI startups? Yeah, admit it. You're trying to do it. My name is Mervi Sepp Rei, and it's my first time here at Devoxx. It is also my first time representing Zendesk. Originally, I'm a cat. This cat is called Klaus. It's an Estonian startup that does QA in contact centers. It's different from QA that the developers are used to. It is a tool where our customers check what the agents are doing to monitor their quality. I've been in the startup scene for 10 years now. There has been many failures. I've been in many companies that one of them actually blew up. One was acquired but didn't do so well. So since I'm Estonian, I like these cheerful subjects of talking about failures. So hopefully there's something to learn here. I'm actually not a developer. I do write code, but to quote my machine learning engineer, my code is not nice. It runs in production for years. Everyone knows that it needs to be refactored and someone needs to touch it, but no one dares to go near it. My background is actually in physics. I studied physics, and I did my PhD in a lab that is more like a startup, or it was more like a startup than it is in academic place. My supervisor, a young angry person, got 2 million from a Wellcome Trust grant and decided to build a systems biology lab. Systems biology is a discipline that combines physics and biology. Obviously, there's biochemistry there, but this is so awful that I don't really want to talk about it. So I was in this very exciting place that I got to build wet lab from scratch. What is a wet lab? Wet lab is a lab where wet things happen, experiments happen, biological experiments happen. So I got to buy analytical scales, centrifuges, and a fridge that sends SMS when the temperature rises above minus 86 degrees, because the reagents and chemicals it carries are bloody expensive. So we were buying the cheapest equipment and building software and like coding interfaces ourselves casually, and by casually I mean through sweat and tears and problems. I've seen one of the brightest minds that I work with when they had to normalize the oxygen consumption of a cell into a unit volume, and if the volume was 2 milliliters, instead of dividing, they multiplied, and suddenly cells were behaving very, very weird. Talking about, they were really the brightest minds. How many of you have used scientific Python, SciPy, NumPy, Pandas? Did you actually know that one of the creators of SciPy was Estonian? Pearu Peterson, 2001, he did this. He was also my supervisor for my master studies. I'm pretty sure that his German Shepherd could do calculus. So I have done a lot of mathematical modeling. I've modeled rogue waves, these murderous waves that appear out of nowhere and bite off half an oil tanker. Solitary waves called solitons that travel very far without losing their shape and energy. This is a very neat property. Optical versions of these waves are used in signal transmissions in the optical fibers. I've modeled how these optical solitons are propagating in photonic crystals in a nonlinear optics lab in Japan. And in this biophysical sphere, I've modeled how energy is transmitted in a heart muscle cell from mitochondria, where it is produced, to myofilaments that perform the contraction. So there's been a lot of very painful, very complex academic activity, and nothing of it is AI. Nothing of it is actually machine learning. My point is that you can do a lot of, you can solve very, very complex problems without any machine learning. My learning from this academia is that Eureka moments are very rare. 86%, it's random number, arbitrary number, but it's just grind and hard work and perseverance, and hard work always is better than natural talent. There's really no such thing. So my first successful exit, I consider, was when I exited academia. So I decided that I don't want to do something like that anymore, and I cultivated myself from a scientist to a data scientist. There was a program in London, and I started doing machine learning, and I started doing natural language processing. So I entered the startup scene doing NLP in the worst kind of NLP that was in Finnish and in Estonia. These are the bloody most difficult languages ever to do anything. And the first thing was actually also dealing with contact center data, and I was building a model that sorted emails in a Finnish bank. So it was a tiny Estonian startup. We had accelerator program with this Finnish bank, and I built a model that went live sorting emails. So it understood if the incoming request was somebody asking for a loan or some kind of other business critical thing, mainly like where the bank could sell something. And these emails were then prioritized higher in the queue. And it was amazing because wait times for this content went from 3 days to 30 minutes, and agents were really happy because customers were really happy that they actually told that, how can you get to me that fast? My learning from this exercise, that was 9 years ago, was that crowdsourcing annotations is extremely painful and really, really hard. We crowdsourced from the experts from the bank ourselves, and the task was to categorize based on criticality into 4 different categories. The agreement between these experts was 23%, so not something very great. And before this tiny Estonian startup had a demo day to decide if they should actually let this thing go live, I had to relabel everything to make this work. The F1 score was 97, it was amazing, it went live, but then I also understood what it actually means to make things live. It's completely different, obviously, than just building with very neat data a tiny model. I left that startup because I saw that it's not really going anywhere, and the trap was that we didn't really have our own data. We had to get someone to give us the data so we could prove that we could use it to something and build something. And then I went to a startup where the stakes were a bit higher. We attempted to get our own data by scraping all of Estonian internet with a goal to classify what the company is doing based on what they write on their webpage. There's this thing called statistical classification for economic activity in the European community, NACA for short, and I attempted to predict what the company is doing based on the internet, what they have on the web page. And why? The reason is that this information can be used in building credit scoring models. That was an interesting place. It blew up. It actually kind of like blew up a year after I joined, and the reason was one of the most common reasons why startups fail. There was a fallout between founders, and what I learned from there is that premature scaling is really bad. We had a setup where there was data scientists, so like people who figured out what we should do and how we should clean the data, and there's nothing messier than scrape data of the internet, and then people who build the pipelines. And whenever they got some kind of module live with a pipeline, we would go and say that, but you have to like add something to the cleaning process. So like this goal, like, but this should work like on all of the possible data from the get-go, actually slowed us down very, very, very bad. And another learning is that if you want to do ML or AI, I use it interchangeably, there has to be a buy-in from a C-level. Like, without that, it's impossible. So after these failures, I discovered that building AI product or making this thing go live can actually be a profession on its own. I went to another startup and I was like a product manager for data and ML products. That was a place where I got my favorite patent. It's also my only patent. But if you ever want to build something that predicts price that has 3-level seasonality, like off-season, on-season, and shoulder season, for example, like plane tickets, you have to ask me because I have the patent for that. And that was an interesting place. It dealt with global mobility, and why we needed to predict the prices of tickets was if major corporations needed to ship people across the planet, they needed to know how much it costs, and then plane ticket cost became a thing. And then COVID happened, and obviously all of this became irrelevant. So my learning from that startup is that if you don't have a model live, you are sacked first when things go wrong. In this startup, there were 2 waves of things going very bad, and in both of the cases, data science teams took the hit. Because in this place, they also approached data science as a vanity project. There was a data scientist who was actually still is the best data scientist I've ever worked with. He was doing PhD with me, so he was amazing. But he worked in a corner doing notebooks, and then someone else's task was to implement it in the product in production. And there was always this gap. So no matter what amazing things he developed, there's always this, look at this is very amazing, my notebook runs, it does this thing, and then CEO is like, oh my God, yeah, this is really interesting, we should definitely do something with it. And the meeting ends and nothing happened. And then came Klaus, and Klaus was amazing. And it was amazing because we had the C-level buy-in. The CTO was really keen on machine learning and AI and all the founders as well. Klaus didn't have the problem of not having data. We integrated with 20 different help desks, so we had our own data to build something with it. And how we set this whole thing up was completely different from before. We started building the pipeline, not this hyper-performing pipeline that I warned you against, but pipeline that does minimal thing to get stuff live. So we didn't attempt to like process all of the possible integrations from the get-go. We selected some where we knew that the customers were like interested in or active in, and that went live. And data scientist, like who had to decide what this pipeline should do, what are the modification we like or transformations we want to do on this text, they were able to modify the pipeline themselves. So write tasks themselves, not deal with the scaling or optimizations. For that we still have machine learning engineers, but pipeline, like a production pipeline for them also was a tool for experimentation. So they could run their samples, very large samples, and take the production pipeline kind of like in an experimental mode, and then decide if it works or not. And then that could go live. And the testament how well it worked was Klaus didn't have any AI, didn't have any ML teams when I joined October 2020. And the first task that we wanted to do was how to find which tickets are complex across all of the customers, across everything. So in October there was nothing, and first product was out to testing in December. So it took 3 months from zero, doing the research, getting the algorithm. It was a statistical method, not a machine learning, because it didn't need to be machine learning. It had no semantic ability or context awareness, but it didn't need to have. It used text as a parameter, but it didn't really understand. But it worked really well because it's statistics. No one can argue with it, and no one can actually test what it does. So pipelines, building them right is the most important thing. Like, no matter how amazing the data science is, but if you don't have a mechanism to produce this or bring this to production, then obviously that doesn't work. But you have to build it in a way that it's not far from the data scientists. So in these pipelines, we built a shit ton of metadata that is boring, and people don't want to talk about it, but this is actually crucial in the down the line ML applications. So think of, like, you know, counting words, counting characters, language detections, like these very basic things for prepping and cleaning. But if you don't bother to do these things, then whatever AI you want to apply with it later can fall on its face. So according to Forbes, these are the top things that companies don't see their data science streams bringing value. I fully agree with those, but it's nicer if I quote Forbes. So first is absence of a specific and relevant problem that needs to be solved. If it comes from business or from product, that please go build me this thing that predicts something, then it's always a bad idea. Second, hard for customers to adopt and use. So what is the UX? The science can be solid, models can be brilliant, but then customers, they don't really know how to use it. Forbes used example for tools that were built in Italy during the COVID. A tool that was meant to figure out where the vaccine should be sent. And people who actually decided where to send these vaccines, they didn't know how to use this tool, even though everything necessary was there, but the dashboards were too complex, and so they reverted back to their good old Excels. And third, poor integration of data science and products. So this decision, what do we actually build? How do we get to this thing? And lack of effort to make people familiar and comfortable with a solution, to teach them how to use it. These are the things. Now I will say how we have solved these issues or tried to solve these issues in Klaus. I start with a third point. Data scientists should be kind of like a product manager, in terms that they should. It's always much more interesting what the problems are to be solved if the scientists talk to the customers, if they understand the pain. Because if it gets like business says that the customers need to, I don't know, do something, and then translates to the data scientist, then like something is lost in the translation. You have to also command what can be built faster, what can be built easier, so that you can, figure out something what to do. Like in the first iteration, if the customer says that I want to find something in the text, regex might work well enough. You don't have to train anything, but it depends on it's always useful for the scientist to be there to understand the pain of the customer, not build AI for the future, but build to solve someone's issue. Coming to Klaus, that is now Zendesk QA, what are the things that we are solving with AI? If the big cat face is all of the tickets that you have in your help desk, then, and the small cat face, if you can even see it, is all of the tickets that pass some kind of manual review. On average is 2%, and this is what 2% looks like. What can you understand from this? Sampling is critical. How do you pick these two things, like content of these two things, this tiny cat? This is crucial. And what is happening under here? It's a very complex data mining exercise that has to take place. And in the QA space or in the contact centers, there are no data miners. So we have to kind of like do this mining for them so that they can, they don't have to do this complex filtering. I want to show you this. This is what the Klaus interface looks like. We have amazing UX designers and visual designers, and it looks pretty, and our customers love it because it looks pretty. And this is to illustrate what actually happens. Like you go, you read through the text, you decide what to put in the scorecard, what you want to grade your agent on. Like for example, someone has to manually check if the agent greeted the customer, if they were empathic, if the spelling and grammar was correct, if they used the right closing, if the agent actually solved the issue of the customer, what was their tone, is the text that they write readability, and if they actually understood the issue of the customer. And we help the customers with, like, in this ticket, churn was identified. I am the agent, and I obviously don't also know how to spell very well, and there was negative sentiment. So like some kind of markers that should help, that maybe something is off here. If you want to improve, check the ones that where something is off, and review this thing. So helping how to do data mining. Then the review is submitted and it's scored, and the quality suddenly gets a number. And you can, if you do this for all of your agents, everyone gets a number, and you have another neat business metric. Another thing that we can solve with AI is this thing that happened now manually, people scoring people, how we can do this completely automatically. So how to make this tiny cat face as big as possible, possibly as big as the entirety of this cat face. So how to go from 2% to 100%. So that's like achieving 50x growth. Finding specific and relevant problems to solve. So what are the things that all of the customers, if you look at all of the customers, what they actually do grade manually. This is obviously something that can be only gotten from the data. You cannot think like make this up, or no one can decide this is what it is. This can be like by analyzing data. And we saw that solution, 88% of the customers actually evaluate manually if people do this thing, if agents solve the problem. Grammar evaluation was second, which was very odd in my mind, because why would you go and evaluate someone's grammar post-fact, where there are so many tools that you can like get the grammar right on the get-go. And then it turned out by talking to the customers that this is because security issue. Tone, another like very abstract thing. What was the tone of the customer? If the of the agent was the agent empathic? Like these top 4 things that people grade manually. And this is where we were in extreme luck. We were prepared to build our own models from scratch. And this is when GPT exploded. And if you imagine the problem like, look, this is the ticket, this is the interaction that went on. You as a quality reviewer, please ask the question if the agent was empathic. This is a thing that you can basically give to any person of the street, more or less. So this is perfect use case for LLMs. Like we look at LLM, we use GPT 3.5. Please look at this ticket and answer this question. And we were also in luck because we had golden data from actual customers. They have done this manually. We ran the same thing for the LLM and checked if we got the same score, so we could verify if this thing works very well. And magically, it works across all of the languages. Like this is what we tell in our marketing. Obviously, LLM language capabilities vary a lot between different languages, but in essence, it works out of the box like that. Everything without any training. So essentially, we used LLMs like a classifier, completely untrained. And with that, we also found if the customer was asking for escalation, if the agent went above and beyond, because that was the thing that people checked manually. And no one obviously grades agents for churn risk, but this is something that is interesting, obviously, for the like whole wider population in the business. This is an example how we solved this UX issue. This example is based on evaluating grammar. So if like it's not hard to deploy a tool that goes and finds grammar mistakes, but we have to also create a score that comes out of it. Not just like you got 5 mistakes, but what does these 5 mistakes mean? So what happens underneath is that we do something that no human can do, or like it would be very cruel to force anyone to do that. That these mistakes have weights, style weighs in less than a spelling mistake, and the number of mistakes is also normalized by the length of the conversation. Obviously, if I manage to do 4 mistakes in one sentence, it looks worse than if I manage to do the 4 mistakes in a 2-paragraph long email. But if you say that, okay, we do grammar evaluation, then someone has to decide what the UX is there. And the UX person, they don't know that, look at that, we can, the tool's output is actually these things highlighted in the pink. Like we actually know this thing. Someone in the front end can map this to the given text. So this interplay or working together with a data scientist who knows the tool, who knows the output, gives that maybe you want to use that to help this thing understandable, is something that we see that it works really well, because like trust is important and making this understandable is very important. So the rave about pipelines, are they actually most important? Well, tech is never most important. The people who build this tech is most important. I am extremely lucky. I have half of my team has PhDs. One is a particle physicist, one is a linguist, one is a gene technologist. There's a mathematician and another linguist in the group. So like you cannot hire machine learning engineers. But what we have seen is you can repurpose backend engineers to be the machine learning engineers. We've had so many bad cases where we hired a machine learning engineer, someone who's very interested in machine learning, but they lack the capabilities of like this, I want to say, core back-end work of sometimes doing the tedious work and making sure that it's alive, that it doesn't collapse on you completely. So we saw that while it's impossible to hire, you can retrain. And to explain how approaching this data science applications has made a big difference. If you talk about text analytics anywhere, then everyone knows about sentiment analysis. We have actually had a customer who came to us and said that we will only sign if you do sentiment analysis in these 5 languages. And multiple have asked different languages, Turkish. And yeah, we have made this available because it's not that hard to extend to another language. But what we saw is that even though this is the thing that people know and ask, they don't really want to use it. So this first thing we built that went in live, something that finds outliers, we see that this is 3 times more popular than sentiment analysis. And that is because it solves the issue that customers have. Another feature that no one asked for. Imagine someone in the product or in the business saying that specking this type of thing. This is a data mining tool. It's an interactive visual filter. You could click on any of these sectors and that would kind of like filter your whole contact center data into this specific spot. With one click, you could find conversations that are by agents whose average score, CSAT score, is lower than all of their peers. So there's like 2-layer statistical modeling that happens underneath. Even though no one asked for it, no one knows what it is, but it is 2 times more popular than sentiment analysis. And the story with our most asked for or the product that gets most traction, how to do this QA completely automatically, auto QA, that actually started as the founder came to me and said that we have to do 100% coverage. Okay, what does that mean? So I approached it from what are the people doing manually right now? What are the things that could be automated? And surely the first things that could be automated, finding greetings, is not the most painful thing. But it was the decision that do we do this or we don't go live at all? Like we couldn't solve the most complex problem at that time. And surely when it launched a year ago, it was pretty crappy. But we have seen over the year now 12 times growth for this feature usage. Obviously, we were in luck. Our pipelines were ready to use different LLMs when they came out, kind of like immediately. And because of this 2.5 years of work of figuring how to prep, figuring out what kind of metadata should be calculated, we could use these pipelines or we could use these LLMs responsibly. Like in the beginning, many customers were super reluctant to let this thing actually operate. What are you doing with the data? Is it used in training? Do you feed PII to the LLMs? And because we have this processing set up at play, we could say that we remove all of the PII before we actually feed it to the LLM. This whole LLM in the production has created like a really weird backslash. Now even if there's a sentiment model, people come and ask if it might hallucinate or if there's a risk of data breach, and I'm like, this is a classifier. It does not generate. It cannot breach or do anything weird. But it's like this battle of explaining to customers, like what does it actually do? What it is actually. So all of this has led to the successful thing that is now that we are part of Zendesk. Zendesk is this very big global help center. As a data person, I am super happy because we don't have to deal with integrating with 20 different help desks anymore. We can build a much deeper integration into this one help desk. My learning from all of this exercise is also that do not succumb to the buzzwords and try to build what everyone else is building. Then you're always falling behind. Try to figure out what is the pain, get the data scientist in as early as possible to identify the pain and figure out the solution step by step. Issues with applying AI or building AI products is that the traction can take some time. We have seen 6 months, maybe nothing really happens, and then suddenly it starts. So in this process, it's also crucial to kind of find your champion customer, someone who is willing to use it, whose problem does it actually solve, that can give you feedback, not just meaningless yes or it helps me or it doesn't help you, but give you specifics so you know how to actually improve it in a meaningful way. And with that, I am done. If you have any questions, there's some time.